Okay, so we have a function f and two variables x and y, and here's the given function. Now what I want to do before we do any calculus, let's just do some algebra. And I want to rewrite this term like this because the square root is the same as the 1/2 power. So I prefer to look at it like that instead of like that. Now, f sub x is the derivative of function f with respect to x. That means when we take the derivative of this, the only variable is x. And these y's are basically constants. They're just numbers. So let's take this derivative. So when we take the derivative here, you would think a quotient rule because you have top and bottom, but not really. Because with f sub x, y is just a constant. It's just a number. So really, this whole denominator is just a constant number. And so what you can do is you can factor out the denominator like that. And so since the bottom is just a constant, you can take it out to the front as a coefficient. And then just take the derivative of the numerator, because the numerator has x's, and right now under f sub x, x is the only variable. So that goes in there, right? Boom, boom. So let's move on to the next piece, plus. So again, you would think that you have two functions. You would think like, okay, that's one function and that's another. So you do the product rule. But nuh-uh, because under f sub x, y is a constant. So really, this whole piece is just a coefficient. So really, the derivative of that would just be this piece here. And let me tell you why. Because you know that the derivative of x is just 1. And this really is the coefficient. So the derivative of the whole thing is just that. It's kind of like saying this. If I asked you, what's the derivative of like 13x? Well, you'd be like, hey, the derivative of 13x is just 13 because that's just the coefficient. That's the same thing here. That's the coefficient of x. So the derivative of that whole thing is just that coefficient there. It doesn't matter that they put it in the back. It's like me putting the 13 back here instead of in the front. It doesn't matter. The derivative of that would have just been 13. So anyways, that's the derivative of that. Now over here, since this has x's, let's take this derivative. So do the power rule. So the 1/2 comes to the front. You keep the inside the same. You subtract 1 from the exponent to get negative 1/2. And then by the chain rule, you multiply by the derivative of the inside, which is just 5. So really, this is the answer for the partial derivative with respect to f. If you want, you can clean that up. So if you want, you could rewrite this into that. If your professor wants you to rationalize the denominator, you can by multiplying top and bottom by this quantity there. And if they do want you to rationalize the denominator, this is what you would get. The point of doing that there is to make the bottom nice and to just leave the top with the square root, because if you have a square root, you prefer it in the top instead of the bottom. So any one of these three should be fine because they're all the same thing. It just depends on how picky your teacher is. Now, for f sub y, we take the derivative of this again, but this time we pretend that y is a variable and x's are all constants. You know what I think would have been helpful? If you rewrite this like that, where you pull out the bottom into the front as a coefficient, and you just leave the top off to the side. That's not a bad idea. So now let's take the derivative of all of this with respect to y. So because x's are constants, this is just the coefficient. So I'm just going to copy and paste that coefficient here into the front. And so really now I just have to multiply by the derivative of this because this has y's. So now let's take the derivative of this piece with the quotient rule. So let's go bottom times the derivative of the top. Bottom is there, the derivative of 1 is 0, minus the top times the derivative of the bottom. So that's minus 1 times the derivative of the bottom. The derivative of that denominator is just 1 over y. And of course, the quotient rule says all over the bottom quantity squared. So that is the derivative of this piece here. Now let's move on there. So here again, this is not a product rule because x is just a constant. So because x is a constant, you just bring it along for the ride. Times. Now let's take the derivative of this. So the derivative of e to the whatever is for sure itself times the derivative of the exponent, which is just 2y. Now the derivative of this is just 0 because we're under f sub y. So this is the partial derivative with respect to y. If you want, we can clean this up. So let's see, this should be it because the 0 is irrelevant. And this 0 times that kills off that piece. So it's negative 1 times that, so it's negative 1 over y in the front. You can bring that beside it. That can stay in the bottom. This can be cleaned up to that. If you want, you could drag that y underneath below it. So yeah, this here should be the pretty cleaned up version of the partial derivative with respect to y. Now, the last thing to discuss is the domain of this function. What can x be? What can x not be? So let's see. Here we have a fraction. Remember that in mathematics, you do not want to divide by 0. So this denominator says ln of y minus 1. I cannot allow ln of y minus 1 to equal 0. We cannot allow ln of y minus 1 to equal 0, because if it is 0, you have 0 in the denominator, and that's bad. So what you can do is create this equation. Create the equation that's bad. ln of y equals 1. Solve this equation, add 1 to this side. And then what you can do is you can make these guys to become the exponents to e. And the reason you do that is because e and ln, they go away. So all you're left with is y, and e to the power of 1 is just e. So what we've just discovered is that y cannot equal e, because that's bad, bad, bad. Because if y is e, and if you plug e in for y right there, it'll say ln of e, which is 1, and 1 minus 1 is 0. So we're dividing by 0, and bad things happen. So for that reason, y, nuh-uh, you cannot be e. Let's see where else. Here, there are no troubles because there's no denominator, and so this x can be whatever. That y can be whatever, because this exponent can be positive or negative or 0. It doesn't matter. There's nothing bad or dangerous here. Here, there's danger, because dividing by 0 is bad, but also square rooting negatives. You don't want to square root negatives. So here is another thing that we cannot allow to have happen. 5x minus 1 cannot be negative! Exclamation point. Because if it is negative, you're going to try to square root a negative number, and we're not trying to play with complex numbers. So here is one thing we have to guarantee ourselves. 5x minus 1 has got to be greater than or equal to 0. It can be 0 because you can square root 0, you just don't want to square root negatives. So solve this inequality by adding 1, and then of course dividing by 5. So x has our permission to be any number in the world that's greater than or equal to 1/5. And I submit to you that these are the only restrictions that must be respected. So I'd argue that this would be our domain. Our domain for function f is the ordered pairs x and y, such that x is greater than or equal to 1/5 and y is not e. And I don't know if you have to tell them things like x and y are real numbers. I'm not sure if you guys are doing that, but anyways, that's the domain for this function f.